everyone, it's Calculus by Christee, and in this video I'm going to go through a free response question that was on the AP Calculus exam in 2021. One of the best things you can do to prepare for the AP Calculus exam is to practice free response questions from past exams. In the description below, I've provided a link to College Board's website where you can find this question along with scoring guidelines and even sample responses. I will be bringing you free response practice until the AP exam, so make sure to subscribe to see those upcoming videos to help you prepare. And comment below about any questions you have, and check out the rest of my channel for videos on various calculus topics. Let's get started. Here is question number 4 from the 2021 AP Calculus exam. And put those graphing calculators away because number 4 was the question that you were not allowed to use your calculator. So in this problem, we are given a graph of f, and it says let f be a continuous function defined on the closed interval from -4 to 6. And the graph of f, as we see, consists of 4 line segments as shown above, and g is the function defined by this integral. And in part A, the question says, on what open intervals is the graph of g concave up, and to give a reason for your answer. So as soon as I see the question talking about when is g concave up, remember that means we need to think about the second derivative. So concavity is always the second derivative, and g would be concave up when g double prime of x is going to be positive. So we need to find the second derivative. G of x is defined as this integral. So let's start with the first derivative. And the derivative of g of x would be, well, the derivative of this integral would simply be f of x. And therefore, the second derivative of g is going to be f prime of x. Therefore, I would want to look at the derivative of the original graph that we are given. So if we want to know when is g concave up, we're looking for when the second derivative is greater than 0, which if I look over here is when the derivative of the graph we are given is positive. So this would also be when f prime of x is greater than 0. So that's going to be when my original graph that I'm given is increasing. So that would be on the open intervals from -4 to -2, because that would be all right here is when f prime of x is positive or f is increasing, and that's also going to be on the open interval from 2 to 6. And the reason for my answer is because g prime of x, g double prime of x, which is the same thing as f prime of x, is greater than 0. Now on to part B. In part B, it says let p be the function defined by this product. And we are asked to find p prime of 3. What I like to do is I first like to find p prime of x. So I first always like to find the derivative in terms of x. And because I have a product, I need to apply the product rule. So that would mean I'm taking the derivative of g of x times f of x plus g of x times f prime of x. Now I like to take the second step and plug in 3. And yes, I do like to take this step because I don't want to make any silly errors. So I'll just go through and plug in 3 for each of these values of x. Now to evaluate each part to find my final answer of p prime of 3. So g prime of 3, well, I already determined in the part above that the derivative of the integral is going to be the same as f of x or f of 3. So if you can see right here, g prime of 3 would be the same as f of 3, and because we are given the graph of f, I'm going to look up here and find that f of 3 is going to be right here at -3. So that's going to be my first value here, and then times f of 3, hey, that's the exact same thing we already found. So that's times -3 plus g of 3. So I'm going to find that off here to the side. So g of x is defined as this integral here that we were given in the problem. So therefore g of 3 is going to be the integral of 0 to 3, because I'm replacing x with 3, of f of t dt. To calculate this, I'm going to calculate the area under the curve of f, which is the curve that we are given, from the x values from 0 to 3. So that means from 0 to 3, I'm looking at the area under the curve. Well, I do notice that this triangle here with a base of 1 and a height of 4 is going to cancel out with this area also with a base of 1 and a height of 4. It's just one area is positive, which is above the x-axis, and one area is negative, which is below the x-axis. So really the only extra area I will need to add is this area here, which you can see is 1, 2, 3.5, but because it's below the x-axis, that area is going to be negative 3.5. So I will add negative 3.5 times f prime of 3, which is going to be the derivative of this graph at 3. So if I look right here, here is f of 3, so I want to find the derivative or the slope of this line right here, and I can see that the slope there is just a positive 1. So then I would put a positive 1, and once again we cannot use a calculator for this one, so we have to just do some mental math, and we can see that it would be 9 minus 3.5, which is a final answer of 5.5 for p prime of 3. Now on to part C. And in part C, we are finding a limit. It's the limit as x approaches 2 of g of x divided by x squared minus 2x. So what I am going to do is I am going to evaluate the limit of the numerator and denominator, and I think we are going to notice something. So if I take the limit as x approaches 2 of g of x, I would find g of 2. And the reason here that the limit of the function is equal to the actual value of the function is because, and I'm going to write this down here, I'm going to write it because g of x is continuous on the interval -4 to 6. And the only way I can equate these two to say that the limit is equal to the value of the function is if the function is continuous. That's the only way I can make this connection. So to find g of 2, well, g of 2 would be the same thing as taking this integral and plugging in an x value of 2. So that would be the area from 0 to 2 under the f of t dt function. And if I look up here at my graph, from 0 to 2, we talked about how this area of this triangle would cancel out with this area because they would have the same exact areas, just one is above and one is below the x-axis. So the limit of the numerator is 0. And the limit of the denominator, so the limit as x approaches 2 of x squared minus 2x, by a direct substitution of plugging in 2, we would have 2 squared minus 2 times 2, which would give me 0. So notice the limit of the numerator is 0 and the limit of the denominator is 0. Therefore, we can apply something called L'Hopital's rule. And if you'd like to see a video that I've made all about L'Hopital's rule, click here to see that video. Now, because we can apply L'Hopital's rule, that means that this limit is going to be equal to the same thing as the limit of the derivatives. And we can only do this because we can apply L'Hopital's rule, because we got this indeterminate form of 0 divided by 0 when we used direct substitution. So now I can take the derivative of the numerator and denominator by applying L'Hopital's rule. And I would have the limit as x approaches 2 of g prime of x divided by 2x minus 2. So now let's think if we were, again, to plug in 2. So g prime of 2, well, we already determined, once again, remember that g prime of x is the same thing as f of x when we took the derivative of that integral that we were given in the problem. So g prime of 2 then would be the same as f of 2, or evaluating up here the function at 2, because this is the f function, and we can see that we get a value of -4. So I would have negative 4 divided by, if I plug in 2 to the denominator using direct substitution, I get 2. So as you can see here, I get a final answer of negative 2. And by the way, if you're finding this video helpful so far, make sure to give it a like and subscribe so that you can see future free response question videos coming up before your AP exam. And now on to the final part, Part D. Part D says, find the average rate of change of G on the closed interval from negative 4 to 2, and then asks, does the mean value theorem guarantee a value of C between negative 4 and 2 for which G prime of C, or the instantaneous rate of change, or the derivative, is equal to this average rate of change? And we will justify our answer. So the first thing I want to find is the average rate of change of G on this interval. So to find that, we would be finding what is called the slope of the secant line, or G of 2 minus G of negative 4 over 2 minus negative 4. So we need to evaluate both G of 2 and G of negative 4. And remember, G of x is defined as the integral from 0 to x, and this was given to us in the original problem, of f of t dt. And I think we actually already found this above. I think we found this, right over here in part C, but you can see the area under the curve from 0 to 2 of f of t dt is 0 because that triangle above the x-axis would come and cancel the triangle below the x-axis. So that one we already found, and that is going to be 0. So now let's find G of negative 4, which, plugging that into the integral that we were given in the problem, would be the area under the curve from 0 to negative 4 of f of t dt. And I always like to go from like a lower number to a higher number, so I am going to change the bounds and go from negative 4 to 0. But when I do that, I always have to change the sign of my integral. So this is going to be negative, and then the integral from negative 4 to 0 of f of t dt. Or we'll figure out the area under the curve from negative 4 to 0, and then we'll make that area negative. So now let's go back up here, and I look at this shape from an x value of negative 4 to an x value of 0, and I'm going to split this into two different shapes. I'm going to split this into a triangle right here, and then this, it looks like that is a trapezoid. And so the area of this triangle I would have is 1/2 base times height, or I would have an area of 6. And then this trapezoid right here, well, you can either use the area formula for the trapezoid, or in this case, I can simply just count the boxes because it's pretty nice. So I have 2, 4, 6, 8, 9, and then 10. So the area together, 6 plus 10 gives me 16, but because I have to apply this negative sign right here, it's going to be negative 16. So now plugging this into my average rate of change, G of 2 is 0 minus G of negative 4 is negative 16 all over 2 plus 4, which would be 6. So I would have 16 over 6, which simplifies to 8 over 3. So that's the first part where it says to find the average rate of change on the interval. So that's the first part of this problem. And then it says, does the mean value theorem guarantee a value of C? Well, there's two conditions that have to be true in order to be able to use the mean value theorem. And if you'd like to watch a video that I've made on the mean value theorem, click here to see that video where I explain all things mean value theorem. So the two conditions that have to be met is that this function, G, has to be both continuous and differentiable on this interval. And so the first thing I would notice is that if I take the derivative, which we found up above, well, the derivative is just f of x. And this function f, as you can see, this function f is continuous on the interval from negative 4 to 6. So therefore, that means G is differentiable on the interval from negative 4 to 2. And so because G is differentiable, well, that automatically means G is continuous because differentiability implies continuity. So therefore, the mean value theorem would guarantee a value of C, where the instantaneous rate of change would be equal to this average rate of change. So I would write that out now in a sentence. Since g prime of x equals f of x, as we stated above, g is differentiable on the open interval from -4 to 2, and therefore continuous on -4 to 2, the closed interval. So the mean value theorem does guarantee that there is a value of c on the open interval from -4 to 2, such that the instantaneous rate of change would equal this average rate of change that we calculated. So that's it for question number 4 on the AP Calculus exam from 2021. I hope you found this video helpful in helping to explain each of the questions and a little bit more even. And if you did find this useful, make sure to click subscribe. I'll be coming out with more calculus videos each week. And also give it a like and comment below about any questions you have or any comments you have, because it's always helpful for the viewers to see those. All right, everyone, I hope you have a great day, and we'll see you in the next video.